Almost every aircraft that flies today carries some form of electronic system. Two classes of aircraft, those for reconnaissance and those for electronic warfare, exist to carry nothing else. The world's first military aircraft was a reconnaissance machine, a balloon, which helped the French army to win the Battle of Fleurus in 1794. Since then, the world of reconnaissance and electronic warfare has grown to embrace aircraft of fascinating diversity. Here we look at those that are flying today, from the mighty AWACS, which can track possible intruders more than 200 miles away, to the Mach 3 Blackbird, taking photographs at over 90,000 feet. Perhaps the cheapest manned reconnaissance or electronic warfare aircraft today is the Pilatus Britain-Norman Defender, though it is quite a large machine with a span of 49 feet. There are several versions, but this is the AEW, or Airborne Early Warning Defender, whose swollen nose houses a Thorn EMI Skymaster radar. This computer-controlled multi-mode radar can look down and see targets even if they are extremely small and flying at a very low level against a background of clutter, the name for unwanted reflections from the Earth's land or sea surface. The operator can select different radar modes for either the AEW or maritime reconnaissance mission. The basic Defender, powered by 320 horsepower Allison turboprops, is agile, can operate from very short unsurfaced airstrips, and hardly costs any more than the radar. The result is the first completely affordable airborne surveillance platform for almost any kind of mission. In the MR role, it can detect and record imagery from ships and from fast patrol boats, and even from the periscopes of submarines. In this role, the operator uses a non-coherent frequency agile mode, optimizing the radar to the detection of small objects out to the radar horizon, even in severe sea states. Highly reliable, the aircraft can lift the radar by day or night to a height of over 10,000 feet. In the air defense role, this increases warning time from 4 to at least 14 minutes. If the Defender carries the radar 100 miles towards the enemy, the warning time is further increased to 25 to 30 minutes. User-friendly in that it is largely automated and simple to switch from one mode to another, the Skymaster radar can guarantee defending anti-aircraft forces adequate warning and information on the direction from which an attack is coming. The Defender's own radar signature is small, and it's protected by its own agility. It could also carry lightweight decoys and other defense systems. It has been estimated that putting a surveillance radar in a Defender multiplies its value to that of 10 similar radars on the ground. The 14-inch display presents information in full color. Raster graphics resembling color television can be used for some information, while cursive or stroke-written characters can be used for letters and numbers. The operator can use a rolling ball to put a small cursor box over any target and, for example, lock the radar onto that target and secure its identity. A second console is provided to increase operational flexibility and target handling capacity. Via a plasma panel, the radar can be used for navigation, IFF, identification friend or foe, or for the integration of ESM, electronic support measures, or an air-to-air or air-to-ground data link, all at the touch of a key. Operating horizon for Skymaster is about 130 miles. At the patrol area, the operator selects the appropriate mode, such as look down with frequency agility to defeat hostile countermeasures such as jamming. The radar can be made automatically to adapt to tracking any of several targets. And the data link or other communication systems can be used to control a direct response to a hostile threat. The computer stores files for all hostile and friendly aircraft. The operator can vector friendly attack aircraft over the best route to a target located perhaps minutes earlier. Alternatively, he can use the displays to track incoming hostile aircraft and vector defending fighters over the optimum path to effect an interception. At all times, a full range of facilities remains available in the surface targeting role. A much more powerful and more costly aircraft which flies the same mission is the Grumman E-2C Hawkeye. Originally built for the U.S. Navy as the standard AEW aircraft for carrier air wings, the Hawkeye today also operates from land airfields with the Coast Guard and Customs Service, and with Israel, Egypt, Japan, and Singapore. It is powered by two Allison turboprops of up to 5,250 horsepower each, and has a maximum takeoff weight of 51,933 pounds. Despite its great complexity and the mass of delicate avionics carried inside it, the Hawkeye has to be built almost like a battleship. On every carrier takeoff, it has to withstand the brutal power of the steam catapults, which could hurl it off the bows at flying speed, even if the parking brake were left on. Hawkeyes can remain on station at about 30,000 feet for up to 4 hours, warning of intruders and directing friendly fighters.
308, 142 at this time. Oh, Roger, I've got him. Control 730.
The advanced radar processing system has over-land as well as over-water capability. It can detect targets as small as a cruise missile at ranges around 160 miles and cover over 3 million cubic miles of sky from sea level to 100,000 feet. The system can automatically and simultaneously track more than 2,000 targets and control more than 40 airborne intercepts. The Lytton passive detection system emits nothing, but listens through antennas facing all around the aircraft, especially on the sides of the tail fins.
I believe I hold a bogey about 308, 142 at this time. Oh, Roger, I've got him. Control 730, I've got a contact now on your 293 at 192.
Every friendly fighter launched is sure to find its target if there is a Hawkeye in the sky. Here, a Hawkeye, the eyes of the fleet, directs an F-4 Phantom.
Bogey 195 at 6. 102 has a contact 190 at 7 miles. Oh, that is your bogey. Roger, Judy. 102, starboard hard. 240. Fox 730. Roger. Gary 102 has a Fox 1 this time. 730, have control, Roger. Fox 2, 102, Fox 2.
Without Hawkeye, the fighter has a vastly harder task and may well return without achieving an interception. At the end of a tough period on station, the Hawkeye is relieved by another and returns to the carrier. Once more, it endures the brutal slam onto the deck and the violent pull of the arrestor cable. Then, as quickly as possible, because it's all bustle on the flight deck, the big electronic station folds itself back into a ship-compatible package. Now the scene changes to the 2-mile runways of the U.S. Air Force. Here, a big Boeing jet leaves black smoke as it takes off on a looking glass mission. These missions, vital to the deterrent capability of the United States, aim to put into the sky a complete duplicate or mirror image of the command and control system that governs the massive bomber and missile forces of the USAF Strategic Air Command. The reason is that were an enemy to strike first, SAC's retaliatory command network might be destroyed. Therefore, since 1961, there has always been a looking glass aircraft on station, high over the United States. On board is a general officer and a team of command and control specialists. All looking glass aircraft have been designated as various subtypes of EC-135. All have high-frequency probe antennas projecting a head on each wingtip, and many other antennas to serve the special communications equipment. While the EC-135 was derived from the KC-135 tanker, these equally special aircraft use the slightly bigger airframe of the Boeing 707 transport. Like the EC-135, they exist purely to carry electronics into the sky, but their mission is entirely different. The Boeing E-3's name Sentry describes its mission, and this is spelt out in the designation AWACS, from Airborne Warning and Control System. Again, like the EC-135, the avionics on board cost more than the aircraft itself. The main sensor is the powerful Westinghouse APY-2 radar, whose antenna is a giant beam carried on pylon struts above the fuselage. On the back of this antenna, which is scanned up and down electronically, are antennas for the identification friend or foe and data links. And the whole assembly, 30 feet across, is then streamlined by adding black fairings at front and rear. The result is called a rotodome, and in use, it rotates 6 times a minute so that the beam sweeps to all points of the compass. On a typical mission, the E-3 climbs to 29,000 feet, takes up station 1,000 miles from its base, and then flies a repeated pattern, often like a typical holding pattern or racetrack, for 6 hours. On board are a flight crew of 4, plus 13 to 17 AWACS operators and technicians. In one arrangement, the operators sit at 14 situation display consoles and 2 auxiliary displays. The SDCs provide the colorful human interface with the mighty radar, which can see virtually everything out to a distance of 240 miles. The operators can control the radar for surveillance over the sea or over the land, or to furnish extra range at the cost of not giving elevation data, as would be needed for aerial targets, or to look far beyond the horizon without elevation data, or even to track hostile electronic signals in a passive mode, in which the APY-2 radar receives but does not transmit. Its time on station can be extended to 20 hours or more by using flight refueling. One of the most important duties of the Sentry is command and control, especially of friendly air forces. Like the smaller Hawkeye, it is a powerful force multiplier. The original E-3A became operational at Tinker Air Force Base in Oklahoma in January 1979. These 707-size aircraft were once thought enormous, but since 1969, they have been dwarfed by the Boeing 747 jumbo jet. In that year, the U.S. Air Force began discussing how this monster could form the basis for the aircraft seen here, the E-4B Advanced Airborne Command Post. Until the B-2, probably the most expensive aircraft ever bought by an Air Force, the E-4B uses the airframe of the 747-200 with General Electric CF6 engines, each of 52,400 pounds thrust. Statistics about the E-4B are startling. On board are 13 separate communication systems. They need 46 antennas, ranging from a super high-frequency satellite dish in a doghouse fairing on top to a very low-frequency trailing wire antenna which can stretch 5 miles below the aircraft. To run these systems needs 1,200 kilowatts of electrical power, or about the same power as the engines of a World War II medium bomber. A 12-hour mission is routine, but using in-flight refueling with a high-speed boom thrust into a nose receptacle, the mission can be extended to 72 hours. Therefore, the crew need all the facilities of a luxury hotel. And this is made more difficult because there can be 94 men on board on 3 decks. In contrast, luxury for the crew of the Navy EA-6B Prowler means being strapped into an ejection seat fastened to an aircraft that is flung off the deck by a catapult and brutally slammed back on at the end of each mission. But the builder, Grumman, is known as the Iron Works from the sheer strength of its aircraft. The EA-6B was derived from the A-6 Intruder 2-seat attack bomber, and it inherits the same high-lift, long-span wings, which bear the takeoff weight of up to 65,000 pounds, much heavier even than the bigger Hawkeye. Despite this, the Prowler can be barrel-rolled like a fighter, and because of its job, it is a popular aircraft on board. The EA-6B carries no weapons, but is packed with avionics. The system on board is the Eaton Corporation ALQ-99F tactical jamming system. This is linked to a battery of antennas in a large cap fairing on top of the fin, which can detect almost every kind of enemy electronic emission. These incoming signals are classified and compared with signals stored in the computerized threat libraries on board, so that almost immediately the crew know what the emitter is and where it is. If the threat is serious, such as that posed by a surface-to-air missile guidance radar, then action will be taken immediately. In any case, the signals are displayed and recorded. All this needs a crew of 4, the pilot and 3 electronics countermeasures officers. If any signal has to be jammed, the task is assigned to one of the active ECM pods. These are hung on up to 5 external pylons. Each pod is powered by an electric generator driven by a small windmill in the nose. The jammers in each pod cover 7 frequency bands, and as there are 2 transmitters in each pod, one facing to the front and the other to the rear, there are 10 transmitters that can all be used at once. With 5 jammer pods, the Prowler can fly 1,000 miles, but it can at any time swap jammer pods for drop tanks of 400 US gallons capacity. Over many years, the EA-6B has been progressively upgraded, and at all times the Navy believes it is kept abreast of hostile threats in its primary mission of protecting Navy combat aircraft. The Prowler is probably the most expensive production aircraft of its size in the world, only rivaled by this gray-painted bird, its exact counterpart in the US Air Force. This is also a product of Grumman, carrying a version of the ALQ-99 tactical jammer system. There, the likeness stops, because the 41 Grumman EF-111A Ravens were produced by completely rebuilding aircraft originally delivered as General Dynamics F-111A bombers. Thus, the Raven is a slick, supersonic aircraft with afterburning engines and pivoted swing wings. Like the Prowler, the Raven groups its passive receiver antennas in the same large cap on the top of the fin. But unlike the Navy's aircraft, the Raven has the ALQ-99E jamming system. Instead of being fitted in up to 5 external pods, the active jamming equipment is installed internally, and the emitting antennas are mainly in a ventral radome, called a canoe radome because of its shape. The 99E is highly automated, so that instead of needing 3 electronic warfare officers, the Air Force aircraft needs only 1. No other aircraft is known with quite the same computerized ability to listen and search for hostile emissions, compare them with a comprehensive threat library, and take appropriate action. If a signal is in the threat library, it will be jammed in a minute fraction of a second. If not, it will be analyzed and recorded and jammed if considered hostile. At all times, the system continues to search for fresh emissions. Though it was originally a bomber, the Raven carries no weapons. Despite this, it can go to war, as in the El Dorado Canyon mission against specific targets in Libya in April 1986. Ravens accompanied attack F-111s from England to jam the hostile radars, a task that appears to have been performed with complete success. It is again a reflection on the importance of avionics that these unarmed F-111s cost far more than those that carry bombs. Again, we have a complete contrast, and yet again the aircraft was built by Grumman. The OV-1 Mohawk was designed in the mid-1950s to provide a reconnaissance platform able to survive in close proximity to land battles and furnish information quickly for U.S. Army field commanders. Powered by two T-53 turboprops of 1,100 horsepower each, it has about the same speed and agility as a wartime Spitfire, but it seats a crew of two, side by side in the bulging, bug-eyed nose. A crucial requirement was that the Mohawk should be able to operate from short and rough frontline airstrips. 380 were built, and many played important roles in Vietnam, some carrying attack weapons. Today, Grumman has rebuilt and upgraded survivors so that the Army can maintain a force of 100 OV-1Ds and 26 RV-1Ds. The RVs are configured for ELINT, or Electronic Intelligence Missions, gathering information on enemy signals of all kinds. The OV-1Ds carry a large pod under the right side of the fuselage. This can be an IRLS, an infrared line scanner, or it could be an SLAR, a sideways-looking airborne radar. Both types of sensor can transmit back to base a clear, real-time picture of enemy territory, even through fog or at night. Some reconnaissance aircraft are specially modified versions of fighters. Nobody needs telling that this powerful machine is an F-4 Phantom II, but it may not be immediately obvious that it is a completely unarmed tactical reconnaissance platform. That was the start of a mission by the 10th TAC Recon Squadron based at Alconbury in England. The U.S. Air Force bought 505 of these RF-4Cs, and the Marines 46 very similar RF-4Bs. They transformed the world's ideas about what such aircraft should be like. With their Mach 2 performance and fit of sensors and other avionics, they are excellent even by today's standards. But RF-4Cs also served in Vietnam. One picture they took was of an SA-2 guideline missile site. Another was of the Hanoi thermal power plant before and after being bombed. Here, the destruction of the Don Phuong Thanh Bridge is confirmed. Also the demise of the Long Dai Railroad Bridge. And this was taken just 150 feet above a very active 57mm anti-aircraft gun. Well might the slogan of the RFs in Vietnam have been alone, unarmed, and unafraid. Even today, the RF-4Cs, first delivered in 1964, are among the very best in the business. The kit includes cameras, an infrared line scanner, a sideways-looking radar, an HF radio with intercontinental range, and batteries of chaff or flare cartridges for protection against enemy missiles. They can roar overhead at extremely low level, get their imagery by any of 4 methods, and transmit some of it during the mission by data link. Camera film is processed in flight and can be ejected in a capsule just where it is wanted, before the aircraft lands. This neat aircraft is also a version of a twin-engine supersonic fighter, but a much smaller one. It is the Northrop RF-5E Tiger Eye, most of which is identical to the F-5E Tiger II fighter. In the tip of the nose is a big forward oblique camera. This is imagery of a dam during a run at 200 feet at 600 knots.
Cameras on. Cameras on.
Just to the rear of the oblique is a large bay which can accommodate several kinds of pallet, loaded with cameras, infrared line scan, forward-looking infrared, or two kinds of sideways-looking radar. This strange device is surely the world's smallest reconnaissance aircraft. Its tiny piston engine is started by an ordinary power drill. Then, after pulling off the tethers, the coaxial rotors start to revolve and reveal an RPH, a remotely piloted helicopter named Sprite. The whole thing weighs just 79 pounds and can be lifted by one man. It can be flown in winds up to 30 knots, and the operator does not have to fly it with the skill of a pilot, but merely commands it to make particular maneuvers. The makers, ML Aviation of Britain, chose to carry one sensor, a TV camera. This sends back a digitized signal, which enables the scene to be studied on the ground and also recorded on tape for subsequent detailed examination. Operating over the front line, Sprite can give a field commander an eye in the sky, from which he receives instant information. Such a machine might be thought very vulnerable. In fact, from little over a quarter of a mile, it is almost impossible to detect. Among its advantages are very low cost, reusability, and capacity to carry various loads. One is a laser designator to mark targets for strike by laser-guided rockets or shells. A useful group of electronic warfare devices such as chaff dispensers or jammers can also be carried. Sprite could operate from a very small ship's deck, and in addition to naval roles, it could undertake drug enforcement surveillance, customs and excise or fishery protection patrols, or act as a communications relay station. Tests have been made with stabilized infrared or TV cameras with zoom lenses, aimed by remote control through a conical field of 110 degrees. The nearly spherical body is only 26 inches in diameter and packed with equipment. The airborne sensor can be black and white, color, low light, or an infrared thermal imager. A precision laser altimeter can hold height above ground at any desired level, such as 200 feet, as here. And Sprite can hover only inches above its target if necessary. For example, to examine an unexploded bomb or a suspected terrorist booby trap. Other applications could include use as a radio relay to increase the range of ground-to-ground communications. Once the engines stop, it takes only a few minutes to refuel Sprite or reload it onto its command vehicle. At first glance, this might be mistaken for Sprite because it is another coaxial remotely piloted helicopter. The Canadair CL-227 Sentinel weighs 386 pounds and is powered by a small gas turbine engine. This gives it a speed of 70 miles per hour and it can lift a comprehensive package of sensors to a height of 10,000 feet. In side view, we can see the oppositely rotating rotors amidships. The engine is in the domed compartment on top, together with a fuel tank, giving an endurance of about 3 hours. The pitch of the rotor blades can be controlled to make the Sentinel rise or fall. Inside the bulging lower compartment are the sensors. These can be a camera, a TV, a low-light TV, an infrared imager, and/or a laser designator, or an electronic warfare package. Canadair did extensive tethered testing to establish the best method of control and target surveillance. Then a Sentinel was restrained by a single vertical cable, which could be useful for recovery to a small ship in stormy weather. Here we see a free takeoff from a field. The remote control is precise, even though Sentinel can be operated at 10,000 feet at a distance of 30 miles. It is reckoned that a Sentinel engaged in a wartime surveillance mission would be neither seen nor heard by an enemy. These pictures, taken in snowy weather, are typical low-altitude images of a kind impossible with a fast manned jet. The day is surely coming when high-quality imagery will be sent back by free-flying aircraft no bigger than some birds. Canadair also make a totally different reconnaissance machine with jet engines and wings. Here is the CL-289, called the USD-502 by the NATO armies which use it. The whole system was developed by Canadair in partnership with Dornier of Federal Germany. SAT of France later joined to furnish an infrared sensor, as well as this radar, which was used to track the speeding vehicle during development flying. Like all battlefield systems, the 502 has to be fully mobile. The basic vehicle is mounted on a rail launcher. It takes only minutes to attach the wings and control surfaces and check everything. On an operational mission, no radar is used, and the USD-502 flies a computer-controlled trajectory according to an accurately worked-out flight plan. Then the launcher is adjusted to the correct bearing and elevation. The small turbojet of 240 pounds thrust is then started and run up to speed. When all is ready, the firing button is pressed. The rocket blasts the vehicle off the ramp and at burnout drops away to the rear. What is left is small, agile, hard to detect, and very fast. Cruising speed is around 500 miles per hour. On board are navigation and control subsystems which would do credit to many manned aircraft. They enable the vehicle to follow a flight plan worked out in exact detail, both horizontally and vertically. A typical sensor pack has a 3-lens Zeiss camera and an infrared line scanner, both giving image resolution as good as that from larger and more vulnerable manned aircraft. Real-time pictures are sent back by secure digital link, so that the ground commander can study the enemy's activity without delay. The computer not only handles navigation, but can also manage the sensors. To reduce vulnerability, this tiny jet aircraft can even hug the ground in a quasi-terrain following mode. On return, it detects and homes on a beacon near the launch site. A signal deploys a two-stage parachute. The CL-289 descends inverted and lands on two large airbags which cushion the impact. It is quickly recovered and driven away to be refurbished for another mission. In almost total contrast is the Harrier, used by the RAF for both tactical reconnaissance and attack. Though primitive compared with the GR-5s and GR-7s now coming into service, the early model Harriers are flown by pilots of long experience. Here, a mission is being flown by No. 4 Squadron. The pilot navigates with his moving map and head-up displays. Instead of weapons, his aircraft carries a belly pod containing 5 cameras. The pilot flies to the target manually, studying the familiar terrain and switching on the pod when necessary to record enemy activity. Harrier is the hardest manned aircraft in the sky to spot or shoot down, being tiny, smokeless, an odd shape, and very agile. For 20 years, these aircraft have had the unique capability of requiring no airfield, and thus of surviving day after day in actual warfare, when other aircraft would long since have been wiped out on the ground. They can be based so close to the front line that reaction time is very fast, with a high probability of catching the enemy unprepared. Under the belly are 2 30mm cannon, while the wing pylons can carry tanks, rockets, or bombs. Having secured his pictures, the pilot returns to his non-existent airfield. There, he makes a vertical landing. The aircraft rolls forward into a hide among the trees. Almost before the Harrier has come to rest, ground crew unload the magazines from the cameras. Within very few minutes, the pilot is being debriefed.
This is my main target. You can just see my main target, but it looks as though the main armor has moved to this area here.
Your target is an infantry combat.
2 fresh pilots are tasked with an attack mission on the armored concentration he had discovered.
That is about 12.
This strike sortie involves 2 aircraft with a full rocket load going out at Mach 0.9 and, nearing the enemy, rolling down almost to ground level to make their attack runs. Another big contrast is the U.S. Air Force F-15E. This is the 2-seat attack version of the Eagle. It is festooned with advanced equipment, most notable being the twin lantern pods. The name comes from low-altitude navigation and targeting infrared for night. Lantern has a navigation pod and a targeting pod, both attached under the fuselage. In combination with the radar and GEC head-up display unit, they enable the F-15E to navigate at a height of 200 feet by night or even in bad weather. The targeting pod gives a clear infrared picture of each target, for example, assisting the lock-on of a Maverick missile. The sensors in the navigation pod almost enable the pilot to dispense with any real forward vision. Instead, synthetic imagery is projected on cockpit displays and on the crucial head-up display, enabling the pilot to fly with greater precision than the pilot of a 1950s fighter on a clear, sunny day. Lantern is also carried by the F-16. And F-16s are also flying with a different and in some ways more advanced system called Pathfinder. More than a dozen companies around the world are producing advanced electronic systems to enable low-flying aircraft to make precision attacks around the clock, no matter what the weather. In most cases, these systems must solve the problem of bad weather landing. It is clear by now that reconnaissance sensors can operate in very different ways. Cameras are at one extreme of the spectrum, using light, while radars are at the other. In between come the infrared devices, and these are increasingly being recognized as of great importance. They emit no telltale signals, as do radars, and because their imagery records not colors, but surface temperatures, they provide far more information. An IRLS infrared line scan can sweep across a landscape by day or night. It defeats traditional camouflage. The resolution or picture quality is getting better all the time. Many companies are doing IR research. Here, a British Aerospace 748 is recording IR images on paper and on videotape. Look at this IR picture recorded as the 748 flew over a tank farm. An interpreter can see the exact fuel level in each tank and can work out many other facts, even the rate at which fuel is being pumped in or out. The aerial line scanner can see far more than the manager of the tank farm on the ground. Here we fly over a large tanker just offshore. We can stop the recorded image and enlarge any part of it. Here is a fast run over an airfield by night and at a height of 600 feet. The amount of information that can be seen is amazing. This aircraft with cold, fuel-filled wings shows it has just landed from a high altitude, the place which an aircraft has just left, and a 707 with its left inboard engine running. As a contrast, this is a British housing estate. Detailed inspection would show which rooms were heated, which chimneys warm, places where cars had recently been parked, and cars whose engines were warm. One amazing reconnaissance aircraft that can use infrared sensors along with others is the Lockheed TR-1. This is almost indistinguishable from the U-2R, and both are enlarged, black-painted derivatives of the original U-2, flown in 1955. In the cockpit, the man garbed almost like an astronaut, as many clandestine missions were flown over unfriendly territory all over the world, with 98% of the atmosphere below the U-2's slender wings. Built secretly for the U.S. Central Intelligence Agency, the original U-2 was an unprecedented kind of jet sailplane, designed to fly at extreme altitudes. Gradually, U-2s became more powerful, heavier, and able to carry more varied kinds of reconnaissance sensor. A crisis blew up on the 1st of May, 1960, when a U-2 was shot down over the heart of the Soviet Union. But in the autumn of 1962, a routine overflight of Cuba disclosed the unloading of Soviet jet bombers and long-range missiles. This posed an obvious and unprecedented threat to the United States. Many countries live under much worse threats, but President Kennedy was having none of it and immediately demanded that such weapons be withdrawn. The U.S. Navy was ordered to turn back any ships heading for Cuba with such items on board. World War III seemed likely to start at any moment. At last, on the 28th of October, the Soviet Union backed down and agreed to remove the threat. And on the 5th of December, the last IL-28 bombers were pictured leaving the island. A great crisis had been disclosed and then averted by aerial reconnaissance. The U-2 and TR-1 are extremely difficult to land. A talk-down truck races after the landing aircraft, telling the pilot the exact gap between the front and rear wheels and the runway.
Tail's way up at 1 foot. 1 foot, tail coming down, 6 inches, hold it off.
When the ailerons become ineffective, the aircraft tips over on one of the electronics-packed wingtips. Every TR-1 pilot wears a pressure suit with a portable environmental control system, like an astronaut. Of course, the ECS is uncoupled once the pilot can connect up to the aircraft systems. Every mission is preceded by hundreds of man-hours of detailed preparation. The sensors can include multispectral cameras, a return beam Vidicon, and a synthetic aperture radar that can bring back imagery of photographic quality. Altogether, the sensors can weigh over 2 tons. The engine is a J-75, once used in an F-105, but with the afterburner removed and completely refurbished. This thrusts the black monster skyward very quickly, the outrigger wheels dropping off the wings as soon as these flex upwards. Few people are allowed to know where the graceful bird is going, but it is assumed that in Europe, the TR-1's mission is to fly just on the NATO side of frontiers with Warsaw Pact nations and bring back detailed imagery of everything going on beyond the frontier out to a range of at least 60 miles and possibly much further. This can be done from about 90,000 feet, from which height the visible horizon is 300 miles away. In February 1982, photographs were published by the U.S. Department of Defense showing the construction of a military barracks near Managua, the capital of Nicaragua. The barracks was Soviet in style. Soon a giant airfield was observed, with runway extensions in progress, though there was no evidence to link this with military aviation. Then Soviet T-55 tanks were seen. Even today, Nicaragua's frontier is routinely crossed by U.S. reconnaissance aircraft. These could be U-2Rs or even the amazing SR-71A Blackbird. Like the U-2 and TR-1 before it, the SR-71 was designed in the world's most secret aircraft facility. Called the Skunk Works, it is part of Lockheed's complex of buildings at Burbank, Los Angeles. It has for nearly 40 years specialized in designing and building the most far-out and challenging aircraft for the U.S. government, and doing it in total secrecy. The Blackbirds resulted from the realization in the late 1950s that mere altitude no longer gave immunity from interception. Enormous speed was also needed, and Mach 3 was the target. A Mach 3, or 2,000 mile-per-hour aircraft, cannot be made of aluminum. New titanium alloys were needed, and fantastic efforts were required to fashion these very difficult metals into almost the whole airframe. Into this fantastic aircraft step a pilot and reconnaissance systems officer. Suited like astronauts, they must be able to escape at heights exceeding 100,000 feet. Every single thing was new and had to be invented, produced, and tested. The hydraulic system had to be designed to work at temperatures much hotter than any domestic oven. Even the fuel had to be special to remain stable at extremely high temperatures and also serve as the cooling fluid for the avionics systems. Called JP-7 and fed by special KC-135Q tankers, it is proof against having lighted matches dropped into it. Not the least of the features of the Blackbird was that it was designed to be difficult to see on radar. It was, to some degree, the first stealth design. And not the least of the extraordinary aspects of this achievement is that it took only 22 months, and all was done in total secrecy. The first Blackbirds were called A-12s. The first flight was made on the 26th of April, 1962, at a remote airstrip in the Nevada desert called Groom Lake. Development was rapid, with up to 18 aircraft in the flight line. 2 were prototypes of the YF-12A long-range interceptor, with a Hughes radar in the nose, flanked on each side by infrared receiver sensors, which are absent from today's U.S. fighters. Underneath was a missile bay, from which could be fired the powerful AIM-47 missile, a giant successor to the AIM-4 Falcon family. The real need, however, was for the SR-71 Strategic Reconnaissance platform. This was made slightly longer and considerably heavier than its predecessors, mainly because of the fuel needed to fly long missions. One SR-71A was converted into this SR-71C trainer, and others were built as dual-control SR-71Bs. All Blackbirds are powered by the unique Pratt & Whitney J58 turbo ramjet engine. At Mach 3, most of the thrust comes from the giant spike in the inlet. Nearly all the rest is contributed by the huge afterburner, which quickly becomes white hot. Training missions have to teach the pupil, who probably has thousands of hours of combat flying, how to manage such frightening situations as engine inlet unstarts when the aircraft tries to swap ends at Mach 3. This SR-71B may be going to simulate such an event as it taxis past the single-plane hangars called barns at the 9th Strategic Recon Wing at Beale Air Force Base in California. Each mission costs hundreds of thousands of dollars. The inward-sloping rudders are fully powered and can work in unison or in opposition. There are no fins. Blackbirds are flown with respect and not aerobated like a fighter. On landing, the 40-ton aircraft is slowed by a giant drag chute. Takeoff weight can exceed 70 tons. Before each mission, the crew eat a high-protein breakfast and again study the mission plan, which has been minutely refined over the past few days. At last, the pilot and RSO walk out slowly to their aircraft, which is being fussed over by mission specialists, concerned with the several tons of highly classified equipment on board. It has been said that the long-focus optical or low-ROP cameras can take pictures from 90,000 feet, in which you can almost read a newspaper. There are return beam Vidicons and sideways-looking radars. Last tasks and checks are completed on the way to the runway. power is unleashed and 172,000 pounds of black aircraft hurtles down the runway and up to the edge of space. Any day, a Blackbird could, if it wished, beat the current world records for speed and sustained altitude for aircraft taking off under their own power. New York to London was once flown by an SR in 1 hour, 55 minutes. Today, Blackbirds are 25 years old, but because of progressive updating, they can do their job better than when they were new. In particular, their sensors and protective systems are ceaselessly being upgraded. Blackbirds are mostly in storage, and missions are less frequent. But in April 1986, it was essential to photograph the targets in Libya struck during the El Dorado Canyon operation. An SR flew right over Tripoli and Benghazi in broad daylight, while the Libyan Air Force fighters and SAM forces were on full alert. It came back with the necessary pictures. This was an unusual mission, because today's frontiers are much more respected, and the U.S. has no wish to provoke any crisis. Occasionally, SRs leave Mildenhall in England and various other bases, but only to fly along frontiers, not across them. Of course, throughout its life, the Blackbird has been extra special. Whenever it appears in public, its huge size, jagged appearance, color, noise, writhing white vortices, and afterburner flames, and its reputation have made it a showstopper. Its most recent appearance was at the 1989 Paris Air Show. As the only in-service USAF aircraft present, the SR-71A attracted plenty of attention, especially from the large Soviet contingent. Pilot Major Jim Greenwood and RSO Captain Steve Grzybiniak spent upwards of an hour talking with the Russians in the friendliest atmosphere. They were, said Greenwood, very diplomatic in not asking any awkward questions. Sadly, the rumors have spread that these great aircraft will finally be withdrawn in October 1989. But already, another product of the Skunk Works has taken over some of the SR's duties, although its range is somewhat shorter. Truly, the reconnaissance mission has come a long way since that observation balloon of 1794.